Hi, welcome to this tutorial with me, Tim Clapham from HoloLux.com, and in this tutorial we're going to be looking at a really cool trick with Xpresso that allows you to expand upon your Mograph rigs by accessing the points, edges and polygons of your individual clones. Now if you're a bit put off by the fact that we're going to use Xpresso, don't worry, we're going to run through this step by step. We're going to start off really basic and then build up until we have a more advanced setup. Here in Cinema 4D, I've got an example of the kind of setup that we're going to end up with. You can see I've got a cloner here with an audio jack as its child. So we've only got one object here, and then I've got another one with an instance of that on the other side. And I've also got a cloner here with a spline, and you can see that we're generating a whole bunch of splines. And the idea is that we take the points of this spline, or of all of these splines, and we iterate through them, and we link them into our audio jacks. I've got the Xpresso already set up on here, it's just disabled. If I enable that, you can see they immediately jump and connect to the jack plugs. Now the cool thing about this setup is that it is 100% procedural, so that we can easily increase or decrease the number of clones, and you can see that as I do this, the rig updates accordingly. So we can take this up into hundreds. Here we've got 355, there we go, bit of an overkill. And you can see that it's working just fine. Let's set that down to a sensible amount, say 50. Okay, and then we've got a random effector, which is just going to randomize the position of those, and you can see the kind of thing that we can create. Now this is just one example of how you might use this. You can use this with any point, edge, polygon object, and you can use it to iterate through regular objects as well. It doesn't necessarily have to work with Mograph, but for me this is a really cool trick that opens up a whole world of possibilities. If you want to follow along exactly, then you need to click on the link with the tutorial that takes you to hololux.com, and you can download this file, but you can just make this file fairly easily anyway. So what we've got in here is we have a spline, which is a B spline, and if we switch to points mode, you can see that we have 4 points on our spline. We've also got an object, which in this example is the audio jack, and you can see here we have the axis, and it's pointing along the Z axis. So to start with, we're going to just create a really simple expression which will allow us to link one of the points of our spline to the position of our audio jack. So with our spline, let's right click, choose Cinema 4D tags, come down and add in an Xpresso tag. That's going to open the Xpresso editor, and you can see that I've got that docked in my layout. I'm going to pull that up. Now you do need to make sure you can see the viewport when you have your Xpresso editor open, otherwise the expression will not be evaluated. So you do need to see the editor viewport. At the moment there's nothing in our expression editor. So what I'm going to do first of all is just grab my spline, drag and drop that in, and this is going to create an object node, and that object node, if we click on it, you can see up here object operator is linking to our spline. So it's not actually a node for a spline, it's just a general object operator, and you can drag any object into there, but we're working with our spline. We need to bring our audio jack in. Again, it does the same thing, creates an object node and links to our audio jack. Now because we want to access the points, we can right click, choose new node, Xpresso general point, and here we have a point node. So it's yellow, which tells us there's a problem, and that's because it isn't linked to an object at the moment. So we need to take our spline, come down, add an object output, link that object into that point node. So now this point node is evaluating the points of this particular object. And you can see if we select our point node, up here we have a parameter for the point index. So we have 4 points on our spline, 0, 1, 2 and 3. We want to link one of those points to the global position of our audio jack. So first of all, with our audio jack, we need to come to coordinates, output the global position. So this is going to output the information as a vector, X, Y and Z values of the position of our audio jack. And we can come to our point node, come down here and we choose point position. If we take this global position, link that into that point position, you can see, boom, immediately our spline point links to the audio jack. I'll just pull this down so we can see it a bit more. If we grab this audio jack, we move it around, you can see, well, hey, it works. Really simple. It's the opposite of using something like an align to spline, which is actually aligning our object to the spline. In this example, we're taking the point from the spline and we're taking that point and moving its position to the position of our object. So that's a fairly simple example, but that's the kind of foundation upon which we're going to build. Next thing we want to do is to create a whole bunch of these with a cloner and work out how we can then create this same setup, but using our Mograph tools. Next, let's come into our Xpresso. Let's just delete the spline and the audio jack object nodes. We don't need those for the next setup. We're going to start using a cloner instead. I'm going to add in a null and just call this Xpresso, just something to hold my expression. Let's select the audio jack, hold the Alt key, add in a cloner object. I'm going to set this to be 5 on X and 0 on Y, and let's make it have a count of 10. Okay, and there we go. You can see now that we've got those. And just to make things a little bit simpler to start with, we're going to take our spline, we're going to create the same kind of thing. We're going to create 10 of these, and let's set them to be the same. But this time, rather than keeping them in the cloner, to make things a bit simpler, I'm just going to press C to make that editable. So now we actually have our splines. So we have 10 splines, and we're going to iterate through these and link them to our cloner. Once we've worked out how to do that, we can come back a step and put these back into a cloner and access the actual spline points that way. By creating this setup using this kind of methodical approach, it will help you understand why we've wired it up this way, and it will also allow you to expand upon it more easily in future projects of your own. Let's take the cloner and drop that into the Xpresso editor. And what we're going to do is we're going to set the object output port, because we want to output this object. Now with a Mograph, there are some nodes specific to Mograph, so let's right click, choose new node, motion graphics, and what we want to do is we want to add in the motion graphics data node, and this allows you to extract data from your Mograph objects, in this example a cloner. So the first thing we need to do is tell the data node what object we want to take the data from, and of course that's our cloner, so we link our object output into our object input. You can then output the information from your various clones. So if we come here, we can output all of this stuff here, and what we want to do is output the position, because we want to take the position of each of those and then link our spline points to it. So that position we're going to link into the point position in our point node. But of course our point node is yellow, it doesn't know which point object it's referring to at the moment, and of course we have 10 splines here, so what we need to do is we need to iterate through all of these splines. Now we can do this by using a hierarchy node. So if we select this top null, right click, choose new node, Xpresso, iterate, and then here we have hierarchy. And because we had that object selected, in fact it's used the object that the Xpresso tag is on. You can see here it's got the reference Xpresso. We actually want to drag that splines into there. And you can see that it has this start path and then an iteration path. So it's down and then next, next, next. So it's going to basically, every time it's evaluated, run through all of these splines, which is great. Now if you think about this, we have, each of these has a number, 0, 1, 2, 3, 4, 5, all the way to 9. With our clones, we also have a number, and on our cloner, we can set the count, and each of these clones has an index. We need to ensure that those two indexes are the same. So when we refer to clone 1, we need to also be referring to spline 1. Now we have a node specifically for this. This is outputting the hierarchy of objects. We need to give each one an index, and to do that we use the object index node. So we choose new node, Xpresso, general, object index, and this is just going to essentially number each of our objects. So we link our hierarchy into the instance here, and then what's going to happen is it's going to output that number. It's going to iterate through all of those objects within that hierarchy, and to make those correspond to the same index of our cloner, we can take this number from here and we can link it into our data node, and that ensures that the number from here is the same as the number on our cloner. So let's grab that index and link that into there. Now the only thing we need to do now is tell our point object our point node which point objects we are referring to, and of course we're referring to this hierarchy. This object index is outputting the instance, which is the object within this hierarchy, and we can take this and link that into our point node. And pretty much that is it. So now what we're doing is we're iterating through our hierarchy, looking at the point, and we're linking that point to the position of each of our clones. So we should be able to grab our cloner and move it now, and as we do that you can see that that is indeed working, and our splines are all linking correctly to our audio jacks. Now we do have a problem that they're not actually flowing out nicely, they're just coming to this point here, and it's not exactly the most aesthetically pleasing, but we're on the right track. So I'm just going to undo to bring that back to where it was. This is definitely a good start, but of course this doesn't solve all of the problems. At the moment we have our cloner generating our audio jacks, but our splines are objects that exist in the object manager, and we have 10 of them. They're not being generated procedurally. So if we take our cloner and reduce the count down, the number of splines doesn't change, and if we take that over 10, we don't get additional splines. So we need to work a way of creating our splines with a cloner as well, and then linking those through. So it's a very similar setup, and this is where we need to include a small piece of Python. It is a very simple piece of code. Trust me, I do not do Python, but I do scavenge the internet for resources and then use them as I can. And this is one such example. This small piece of Python code will open up a whole world of possibilities for your Mograph setups. Now I've actually got that on the clipboard, so I'm going to just paste it into my Xpresso editor. And if we select that Python node and have a look in the attribute manager, you can see up here that it's a very small piece of code. The part that we're interested in really is this line here, output1 equals input1 dot get cache. So all objects within Cinema have this internal cache, which is used to do all the calculations. For example, with a cloner, we only see one object, but internally it's going to be generating all of the clones that we set on our count. And this cache allows things like effectors to access each individual object and do its stuff. Another example might be something like an extrude NURBS. If you make that editable, you can see all the internal parts, which is the extruded part, the fillet, and the caps themselves. So internally, if you access the cache for that, you will access all of those parts. And you can see that if you work with the external compositing tag, this has a cache parameter on here. So if you use this external compositing tag on a cloner, for example, it will output a null for all of your children, and if you uncheck cache, it will only output a null for the actual object itself. And that's the same cache that we're referring to in our Python. So we need to create an input so that we can output the cache, and at the moment our splines are all in this null. So let's just take one of these and grab that, and I'm going to delete that group. Okay, and with this spline, let's just duplicate this cloner. We'll call this cloner splines. Get rid of that audio jack and put that spline in there. Okay, so now we have all of these splines in our cloner. I'm just going to pull this back here. We can grab this cloner splines, drop this into here. Let's create an object output. So this is the object we want to take the cache from. So we link that into the input on our Python node, and that's essentially going to output the virtual hierarchy of that cloner. And because it's outputting a virtual hierarchy, we can then link that into our hierarchy node, and then the rest of the setup should simply just work. So we create this output, link this into our object, boom, and you can see all of those splines now link into our audio jacks. And if we grab this and move it around, it's working as expected. But the cool thing about this now is that it is procedural, so that we can take our cloner and our cloner splines and we can increase the count of both, and you can see that it is working. And if we grab this and move it, that is now working. So you could have as many as your computer will allow you to work with. I guess the most obvious thing to do now would be to create another set of objects to connect to the other end, and that's extremely simple to do. Let's just tidy this up a tiny bit. And we've got this point node here, and I know that this is linking to index 0, so I'm going to call this point 0 and just pull this up above. Let's move this so we've got a bit more room. Let's take these and just move them up here. And we're going to link to all of the points of that spline eventually, so I just want to keep them in order, just so my brain doesn't have to calculate too much. To create another object at the other end, I'm just going to take my cloner. Let's call this O1, and let's just duplicate this. Call this O2. I'm going to get rid of that audio jack and instead just be a bit more efficient and use an instance. Now if we take this and rotate it around, whoops, like so, and let's set that to be -5. Okay, and pull this one out over here somewhere. So here we have the two cloners and our splines. Come back to our Xpresso. All we need to do is take these, hold down Control and drag that down. So let's call this one point 3. We have 4 points on our spline, 0, 1, 2, 3, and we're going to set the parameter here to be 0.3. We want cloner 1 here to be cloner 2 because we're going to be linking to the position of these objects. And of course the object that we want to use as our point object is the spline, which is accessed through this hierarchy. So we take the instance from here and we link that into the object of this point node. As soon as I let go, you should see the points link, and you can see that they've all linked to the first clone. And this is because our data node here hasn't got a link into the index. So the index here is set to 0. If I click this, you can see it jumps through. But of course we don't want to do that. We want to iterate through all of those, and we're going to use the same index as we are with our splines. So we also take our index here and link that, and there you go, and you can see that now that's worked. And now we should be able to grab our cloner and move that one around. We should be able to grab this one and move it around, and you can see that as we do that, the spline points follow along accordingly. The other thing that's probably a good idea in a setup like this is to link the count of all of the objects, just so that we don't have to go through and select all of our clones. So you can do that just based on the number of splines, for example. So we could take our cloner splines, we come here, we choose object properties count, and then we just drag this and we link it into the others. So we choose object properties count for the input here, and we do the same down here. And now if I select my cloner splines, I can adjust the count, and you can see that that adjusts all of those cloners. So now we've got this nice procedural setup where we can link the points of generated objects to the position of our clones. And of course you could link them to the points of the clones from the points of another clone, and you could do this using any type of object. Doesn't have to be a spline. As long as the object has points, edges or polygons, then this technique should work. So the next thing that I want to solve is just how we can make it so that these cables always come out the back of our plugs. At the moment you can see it's not very convincing. We need that to flow out of here. Well, probably the easiest way to do that, if we come in close and have a look, is to constrain the second point of our spline. So we have a point here, we have one here, we have one here, and we have one here. And we need to constrain the second point to be somewhere along this Z axis for our clones. So coming down into our Xpresso, let's just have a look at how we could set that up for one end. So I'm going to just take this point here and copy and paste. And let's take this point node and we'll call this point 1. And we'll set the parameter to be point index 1. Now of course we need to link that to our spline just as we did before. So we can take the instance from here, link that into the object. The point position, however, is slightly more difficult, because what we need to do is we need to take the position of our clone and then offset it. So you can see that at the moment the result is far from ideal. Let's just have a look, and you can see that we're getting this weird curve. Okay, not working as expected. They're all linking, they're all pulling over to the position over here. And if you look at the point position value in this point node, you can see that it's got 0, 0, 0. And we want that to be a value that's based on the cloner position, or the clone's position, and we just want to offset that. So if we take the position out of here and link it, of course that's going to be in exactly the same place as point 0. But what we can do, because this is a vector with its x, y, z parameters, is we can split that out. And this may seem like the correct solution, which is why I'm showing it to you, but actually there's a simpler way. Let's just choose new node, Xpresso Adapter, and you can see here we have a way of splitting out matrices to vectors, vectors to reals. So we want to go vector to real, and what that does is it allows you to input a vector, which is our position, x, y, z, and then it outputs the values as separate ports. And we can then convert that back to a vector and input it into here. And to do that, we choose new node, Xpresso Adapter, reals to vector, and then we output the value of this into our point position. So if we take the x and link that across, that's going to be the same. If we take the y and link that across, that's going to be the same. And then what we can do is we can add in a maths node and just add an amount onto here. So let's choose new node, calculate math, and we drop that in between our z value. So at the moment that's adding 0. Let's just rotate around. But if we drag this amount up, you can see that it's pushing that point across here. I don't know if you can see that, but as I drag that, you can see that that is moving. And if we grab our cloner, move it, you can see that now it's kind of working. You can see that it's pushing that point out along the z-axis. Even when we do this, it's still trying to push out. Maybe we make that a bit higher, like so. And you can see that now, it doesn't matter where we put these, or so it seems, it's going to output along there. Because it's basically taking this position and then offsetting by this amount the position value and linking the point to it. But the big problem with this setup is that it's based on world coordinates. So by using this position and this process, it works, or it appears to, but if we rotate this cloner around, you can see that it doesn't work because it's still offsetting it based on our world position. So now the wires are going through. So that's not actually the solution we want. So let's just undo to bring that back round. There's actually a much easier way of doing it, and what we have to do is we simply just take the matrix of our objects and we multiply that with a vector with the offset that we require. So let's just come in and delete these nodes here. With our data node, we're going to output the global matrix, and the global matrix contains the matrices of our object, which is a bunch of vectors which tell us the position and the orientation or direction of our object. Thank goodness for programmers creating these nodes for us, because honestly I wouldn't have a clue otherwise. And it was only through a little bit of Googling that I found this solution, and I found a way that someone had done it in Python and realized that you could do that using pure Xpresso, well, apart from this small Python node. But the actual multiplying the matrix with the vector was the solution that I needed. So we can add in a node for this. It's Xpresso calculate matrix mul vector. It's a catchy name. And we grab our global matrix, we bring that in here, and you can see now we have a vector here, x, y, and z, and then we output this to the point position. Okay, and now because that's set to 0, it's put the point in exactly the same place. But if we take this and we add some to the z, you can see that now that's the Z value. But the cool thing about this is it's now using the local Z. So the matrix mul vector allows you to multiply a local vector with a global matrix equals a global vector. Suffice to say it works, which is just great. And you can see that now wherever I move this and rotate it, the cable is coming out in the right direction. Let's just undo. If we come down to the expression, let's take point 1, just drag this to create a copy, and it's gone underneath. Great. Let's just call this point index 2 and name the node so we know that's what it's referring to. We want to take this matrix mul vector and copy, no, not cut, copy and paste. Okay, and we're just going to do the same thing that we did at the top here, add the global matrix. Let's just pull that up and we drag that into the matrix. Our object is from our spline hierarchy and our point position is this vector here. Now we need to take this and adjust the parameter, and I think probably we need to use a minus value. Let me just move one of these. Oh no, we do need to use a plus value here. So let's set that to say 150. Let's set this one to be 150, so they're the same. And now we should be able to grab and move any of our cloners and our cables will still flow out correctly. So if we select both of these, come to the Mograph menu, just choose to add in a random effector. Okay, and you can see that you do get this delay sometimes, but when you press play, it should be fine. What I'm going to do with this random effector is I'm going to choose noise, and I'm going to add some rotation. Let's set this to be, say, 20. Okay, and now we can press play, and you can see that it's working. And there we go. And of course, as you already know, this is a fully procedural setup, so we can quite easily come here and we can just increase the count and it still works perfectly fine. So it did get a little bit vector math towards the end there, but I hope you enjoyed that tutorial. It's a really great technique and will allow you a lot more control over rigging your Mograph setups. And as I said before, obviously we're using this with the Mograph data node to extract the position of our clones. But you could use this with several point objects or just hierarchies of objects. There are many uses for this. And if you want to learn more about rigging, then please head on over to hellolux.com. We have Learn Cinema 4D Rigging in One Day, which covers this kind of thing, plus a lot more besides. Don't worry, it's not all Xpresso. There is some Xpresso there because it's definitely a very powerful part of our tool set, but we also look at rigging with traditional deformers, using joints, and many other techniques which are useful in your day-to-day motion graphics and animation tasks. So thanks very much for watching. Hope you enjoyed it, and I'll catch you next time.